So 3.2, and we're looking at arithmetic series. Now the difference between an arithmetic sequence or an arithmetic progression and an arithmetic series is that we add the numbers up. So for a series we do 5 plus 7 plus 9 plus 11 and so on. Well, the sum of the series is what you get if you add the things up. Now sometimes we're a little bit loose with the word series and sequence, and don't worry too much if that happens, if people are saying series when they mean sequence or sequence when they mean series. With a series though, we're talking about adding the numbers together. So we have a new notation Sn, which means, so if Un is the term in the sequence, Sn is added up so far, okay? So with this sequence here, for example, U4 is the number 11. It's the 11th thing in the sequence. S4 would be the answer to 5 plus 7 plus 9 plus 11. So, let's see if my mental arithmetic is getting there. It's 32. Okay. So there's our Sn and our Un, and we've got to make sure we don't get the two mixed up. And we need to know the formula. We know the formula for Un. It's a plus n minus 1d. We need to know the formula for Sn, and we need to know the proof of the formula for Sn. So it goes like this, and they can ask you on the exam what the proof is, by the way. So this is one of those that you need to make sure you've got a good way of writing it down before you hit the exam. If you're at all unsure about that, then work out a way of writing it down, show it to your teacher and say, would this do? And then when you hit the exam, just make sure you've memorised your particular way of doing it with all the stages in there. Now here's the way of thinking about it. We're not going to prove this for an arithmetic sequence yet, or an arithmetic series. We're just going to look at the numbers 1 to 100. And the story goes that Gauss, who was a famous mathematician, his teacher decided to give the class something to do while he had a little bit of a nap and didn't have to work too hard. So he said to the class, right, add up all the numbers from 1 to 100. And 2 minutes later, Gauss turned up and said, I've got the answer, now what do I do? And the teacher was very annoyed. I, again, don't know if that's true, but it's one of the little historical stories. Now, if you think about that, add up the numbers 1 to 100, how are we going to do that? That's not something we can do quickly. 1 plus 2 plus 3 plus 4 is perhaps not too bad, but once we're starting to add up all, numbers in the 40s and 50s and 70s, it's going to get quite tricky. Well, here's the trick. I'm not just going to write the numbers down once to add up, I'm going to write them down twice, which you'd think might make it twice as hard, but no, it works like this. I'm now going to add up all of the numbers in this first list and all of the numbers in the second list, and I'm going to do it in a clever way. Because I've paired them up, I've written them forwards and I've written them backwards. Well, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101, and so on. So what I've got is 101 100 times. Okay? So if I add up everything in the first and second lists, that's the same as just adding up 101 100 times. So 101 times 100. Now the problem is, I only wanted everything in the first list, so I've gone too far. That's too big. So what am I going to have to do? Well, just half it, look, because everything on the top is the same as everything on the bottom. Everything in the first list is the same as everything on the second list. So if I do 101 times 100 and half it, I've got my answer. Well, 101 times 100 is 10,100, and half of that is 5,050, and there's my answer. There's the answer to add up all the numbers from 1 to 100. That was the clever thing that Gauss thought of when he was at school, and we are going to use that to give ourselves the formula for the sum of any arithmetic series, and it goes like this. So an arithmetic series looks like this: A plus D, A plus 2D, and so on and so on and so on, until eventually we end up with A plus n minus 1 lots of D. What came before that? Well, it was A plus n minus 2 lots of D, and A plus n minus 3 lots of D, and so on, right? Now let's take the same trick. Let's write this down backwards. A plus n minus 1 lots of D, A plus n minus 2 lots of D, A plus n minus 3 lots of D, and so on until we get to A plus D, A plus 2D at this end. Okay? Let's add together these pairs, and what we're going to get? We're going to get A plus A, which is 2A, plus n minus 1 lots of D. So that one's not too bad. Now, A plus A, that's still 2A here. Now, D plus n minus 2 lots of D. Well, think about that. This is this many D and one more. So I'm going to end up with n minus 1 lots of d. Now if you really don't like that, well, expand these brackets out and add it together and you'll see that's what we get. When it comes to the exam, you don't need to double check that, you just know that these pairs all add up to 2a plus n minus 1 lots of d. Okay? So, and the reason you know that is because you've seen it before, you've seen it here, and you remember the example of the numbers 1 to 100. When you pair them up, they all add up to 101. So here, the same thing happens. They're all going to add up to the same thing on the bottom. If you want to double check it, you know, check that this and this add up to a plus n minus 1 lots of d, then you can do. But if you think about it, you should be able to see it after a bit of thought, because I'm adding on d here, I'm taking away d here. So the sum of the two things should be the same, because this one gets d bigger, this one gets d smaller, right? So I've got these things in the list. How many of them are there? Well, there are n of them. It's 1, 2, 3, up to n. So there's n lots of 2a plus n minus 1 lots of d. And that's what I've got in the bottom row. But I want to half the answer because I added up the numbers that I wanted twice. So n over 2, 2a plus n minus 1d. Another way of writing that is this, n over 2. This is the first term plus the last term. And all of these things are equal to the first term plus the last term. So we sometimes introduce an L, meaning the last term. So n over 2, a plus L, and sometimes that's a helpful way of writing it. So the sum to n terms of an arithmetic series is this formula, which means if you add together the first n things, you get this. So for example, if I wanted to add together the first 10 terms, I would write S10. That is 10 over 2, 2a plus 9d. If you know what the first term is and you know what the ninth term is, you can work out the sum of the first 10 terms, or any other number you want. Now obviously we've got a formula here with an Sn, an A, an N and a D. So what they're going to do is they're going to give you questions where they give you the A and they give you the D, and they give you the sum to the first 6 terms, and then they try and ask you what's, you know, they give you A, they give you D, they say the sum of the first so many terms is this number, what's n? And you have to find how many terms there are. Or they're going to tell you how many terms there are, they're going to tell you the sum, and they're going to ask you to find A if the common difference is a certain number, right? They're going to ask you to use a formula, as they always do, and they're going to ask you nasty different versions of it. A typical thing might be the sum to the first 3 terms is this, the sum to the first 6 terms is this, what are A and D? So you'd say, well, S3 equals 3 over 2, 2a plus 2d. And if you know what the sum to the first 3 terms is, you write that in there. If you know the sum to the first 6 terms, then S6 equals 6 over 2, 2a plus 5d. If you know what the sum to the first 6 terms is, you write that in there. You've got 2 simultaneous equations with an a and a d, and you can solve from there, that sort of thing. And I think that is everything, really. Example 7 tells us that the other sort of thing they can do, find the least number of terms for a series to exceed a certain number, okay? So let's just have a quick look at it in the book. Those terms need to add together to more than 2,000. Well, those terms, the sum of those terms is given by this formula. You put it in that formula and you solve it, and you get that n is equal to 28 or minus 28.6. Now, if you do that exactly, it actually comes out as 27.9 or something like that. So 27 terms isn't enough to add up to 2,000. 28 is enough to add up to more than 2,000. So 28 is the final answer they give us there. Right, under section 3.2.